We know that projectile motion is parabolic, but where does this come from? Let's prove it. We'll take the object to be at the origin of the xy plane, launched with an initial velocity v0 at an angle theta to the horizontal. We can resolve this initial velocity into a horizontal component and a vertical component. To prove that the motion is parabolic, we're going to need to come up with an equation relating y to x. Ignoring air resistance, the only force acting on the object is the force of gravity, so the acceleration is vertical and is equal to g, the acceleration due to freefall. This means that the horizontal velocity is constant since there is no horizontal acceleration. So Vx is always equal to this Vx0, meaning that x is equal to Vx0 times time. The vertical velocity, on the other hand, is continuously changing due to the vertical acceleration, so we're going to need a kinematic equation to represent y as a function of time. Again, the vertical acceleration is negative g, and this gives us the equations for y and x. Although we're considering the horizontal and vertical motions separately, they're not disjoint. They're joined together by the time t, because it's the same journey. So we can find t from the first equation and plug it into the second equation. Let's bring the x outside like that. Apply the square top and bottom on the second pair of brackets and rearrange. Now, the red stuff are constants, so this is basically an equation y equals ax minus bx squared, a quadratic function and therefore a parabola. Because the leading coefficient is negative, the shape of the parabola will be like an N and not a U, which is exactly what we expect. Also, we can factorize this equation and find the x-intercept by setting y to 0. This gives us x equals 0, the starting point, but also x equals a over b, which is the final point. From this, we can find the range, r, of the journey, which is the horizontal distance the object covered.